Hello students, today in this video I am going to do numericals based on modulus of rigidity, and specifically it is continuation of Young's modulus. We already know that Young's modulus is equal to linear stress upon strain. In a very simple term, we will write that any modulus is some stress upon strain. Stress is basically force acting per unit area, and if it is in terms of linear, it is change in length upon original length, which we can write it as F upon A into L goes up L upon delta L. So this is the basic formula we should remember. In today video, I am going to do numericals from IIT question main examination. So the first question which I am going to solve today has come in 2019 paper JEE main. Okay, so let me read the problem first and then we shall proceed. A steel wire having a radius 2.0 mm. A steel wire. First material is steel whose radius is equal to 2.0 mm. Convert it into meter, 10 power minus 3 meter. Carrying a load of 4 kilogram. Load, mass is equal to 4 kilogram. And you know that from here we can say weight is equal to 4 into G, right? That is 10. Let me just read. Given that G is equal to 3.1 pi meter per second squared. It is given here. It is not given 9.8, instead of which it is given 3.1 pi meter per second square. It's very simple, right? Same thing is given in 3.1 into 22 by 7 or 3.14, you can use it. Okay. What will be the tensile stress? Tensile stress. We want to calculate the stress. Okay, we will write here tensile stress is equal to, okay, force upon area. That is equal to, what is the force? Force is the weight of the body acting downward, gravitational force, which we can solve it here, right? This will become 4 into 22, 88 multiplied by 3.1 upon 7. That is equal to, let me just try this problem with you, okay? So then I will do the other problem. So 88 multiplied by 3.1, right? That is 8 8 3 24 மீது 2 8 3 24 26 8 2 7 2, right? So 272, okay? Okay, one more step is there. 272.8 divided by 7, okay? 7 we will do with it. 8 3 27 4 3 times, okay? Move 21, okay? 6 is remainder, 2 62 7 49 8 56 9 73, okay? As we can take 8 times 56, okay? That means we have say 4 plus 2 6 68, okay? 0.9 times, okay? So 38, the total value for this is 38.9 Newton. Okay, so we will take this value up over here. So let me erase this in calculation. That is, force is 38.9 upon area. Again, it is circular in nature. So area of circle here is pi r square. So that is equal to pi. See, we could have made a cancelled pi value. I think I did it little in a hurry, okay? So we can say pi into r is 2 into 10 power minus 3 the whole square. So pi into 4 into 10 power minus 6, okay? So this we can take it, if you want you can multiply this pi could have got cancelled. Okay, so let me just bring it here like this. Can I simplify it? Let me see, right? Let us keep pi as it is, right? Here 1 time 18, 2 times 14, 4, right? Point we will keep it 4, 7, 49, 35, 5 pi. Okay, this will be better. So that we can cancel it. 12.5 pi divided by, this is pi into 4 into 10 power minus 6. Pi gets cancelled. That is equal to, it goes up. 10 power 8 is there. Sorry. Plus 6 will become, okay, 4, 3 times, 1, okay, then it becomes a 10, 2, right? Stress force upon area, this is going to be Pascal or Newton per meter square. Okay, let us see what are the options given. Yes, I will tell you what are the options given in this. 4.8, no. 3.1 into 10 power 6, so Newton per meter square, 6.2 and 5.2, so that is the answer. Dear students, I want to tell you one thing. See, first I attempted blindly, this pi is given, so do not change that pi. Somewhere when you take this pi, it's going to get cancelled, so always sometime look at the data and what is necessary to reduce it. What is cancelable, cancel it. Because you are writing an examination like JEE or NEET examination where time management is very important. So I suggest you be careful in converting the units. Is it necessary or not? That you will get it by practice. Then I will do another 2 problems with you today. Yeah. And these are the problems which have come in NEET examination, right? So first one I have done from JEE main 2019 paper. The second problem which I am going to do is from NEET. Okay, let me tell you which year it has come. Yeah, this problem is come in NEET 2018. Okay, NEET 2018. Dear students, you can follow any book, but always follow one book and complete that book thoroughly. Whether it is your textbook or whether it is some support book, whatever you use it thoroughly. Do not shift from one to the another. Being a teacher, I refer to multiple books actually. I don't restrict myself to one particular book. I use multiple books like D.C. Pandey, and I use Tata McGraw-Hill, N.K. Bajaj, and I use different company books. I use it, and I also use MTG publication. I also use what do you call we have Arihant publication, and I have Sahitya Academy, that means Sahitya Bhavan publication. So I use many books, I collect them, and I'm trying to do this video for you. Okay, so 2018 paper. 2 wires are made up of the same material. First, mark it. 2 wires are made up of the same material. So same material means what? Young's modulus is same. Okay. And have same volume. Same volume. So same volume means what? V. V is same. We know V is equal to A into length. Right? So V, if I say AL, and what will happen to some other value if it changes? The first wire has a cross-sectional area A. The first wire, there are 2 wires are there. So first wire and the second wire. The first wire has a cross-sectional area A. And the second wire has a cross-sectional area 3A. See, it is 3 times. One is cross-sectional area A, another is having 3A. Okay, so when this is 3A, you know volume being same. So A becomes 3A. Naturally, volume is same. So length has to become L by 3. Keep this in mind. So naturally, this will be L and this will be L by 3. Okay, fine. If the length of the first wire is increased by delta L, if the increase in this is delta L, okay, on applying a force F, You apply a force F. Okay. How much force is needed to stretch the second wire by the same amount? See, again delta L is going to be same. Delta L of the first wire is equal to delta L of the second wire. So let me write it, delta L of first wire is equal to delta L of second wire. Now the question is, how much force is needed to stretch the second wire by the same moment? Okay, let me call it as F2 and let this be F1. Once you have taken the data, you can easily place the question aside and think how we can proceed further with this. Okay, see, we need to calculate the forces. Same material. Okay, so let me take the formula precisely in this place, right? So I will take it here. Y is equal to FL upon A delta L. Here both of them are having same, delta L is same, okay, delta L is same, Y is same material is being used, okay. Now force we need to change, area we have, length we have, okay. So what I am saying is, let me get space for it, solving it, okay. Let us say del F is equal to, this is also same, F is equal to A divided by L. F is equal to, or I put proportional because other things are constant. Okay, so A divided by L is proportional to F. So F1 upon F2 is equal to A1 upon L1 divided by A2 upon L2. That is equal to A1 upon L1 multiplied by L2 upon A2. That is equal to A1. A1 is A only, L1 length is L only, multiply by L2 is L by 3 and A2 is divided by 3A. So L gets cancelled, AA gets cancelled, you get 1 by 9. Okay, so you get that F1 is to F2 is equal to 1 is to 9. Okay, so or we can say F2 we need to calculate. Okay, F2 from here we can say F1 upon F2, right? F2 is equal to 9 times F1. Okay, so this is the answer. So let us check it. What is the answer, right? I have solved it in my book. Okay, F2 is equal to 9 times F1. So this is how you can solve the problems. Don't worry about the examination paper. Always remember, if you are clear with the concept, you will not have any problem, right? So let us do one more problem for this particular video session, right? And then we will move on to the next concept. Okay. Yeah. Okay, once again, let me tell you what is this problem. Same thing I have taken, book is same, the textbook I have taken, right? And mechanical properties of solids. This is from 2015 paper, 2015 NEET. Okay, all these are from NEET exam. Let me read the problem again. The Young's modulus of steel, the Young's modulus of steel is equal to twice that of brass, twice that of Young's modulus of brass. Okay, first step. Two wires of the same length and same area of cross section. Same length and same area of cross section. What does it mean? Volume is same. Okay. Are suspended from the same roof. Think this is the roof, right? One is steel, another is brass. Okay. If we want the lower ends of the wire to be same level, the lower ends to be at the same level, what does it mean? delta L is equal to 1 is equal to delta 2. The extension should be same, then only the lower levels will be same. So that is the first point we should notate. If we want the lower ends of the wire to be the same level, then the weights added to the steel and the brass must be in the ratio. What should be the weight added? W1 and W2. You know W is nothing but is equal to F, the force, gravitational force. What is the ratio we have to calculate? Okay, dear students, I hope you understand the problem. You can download it from the net. These questions are easily available. 2015 you put it, you will get it. 2018 you put it, you will get it. Yes, again I go back to the prime formula. Y is equal to FL upon A delta L. A delta L. It is given length is same, area is same. The both delta L has to be same. Okay, delta L is also equal. So what does it mean? Y is proportional to F. Okay, we can say, or otherwise F is proportional to Y. Okay, what does it mean? F1 upon F2 is equal to Y1 upon Y2 ratio, right? So F1 upon F2 is equal to Y1 is that of the steel upon Y1 is equal to, if you call this as Y1 is equal to 2 times Y2. So 2 times Y2 upon Y2, Y2 gets cancelled. You get F1 upon F2 is equal to 2. We wanted to know the ratio of F2. So we can say F1 is to F2 is equal to 2 is to 1, and this is the answer. 2 is to 1 is the forces between them. Okay, let me cross check once again. Yes, it is same. Dear students, I also put a notebook and I also solve this before I shoot video, because I may have experience. I am teaching physics for the last 35 years, but I think that every time we need to prepare once again so that we can shoot better videos. Yeah, so this is what it is. So dear students, in the next video I'll come with more problems, maybe on bulk modulus and then shear modulus, and we will go further and further. Thank you so much.